Thanks very much, everybody, for being here, and thanks for the introduction. It's great to see this happening at this time, and it's a fantastic time to be in the modular construction industry. I'm Patrick O'Callaghan. I'm the CEO, as you see there, of Offsite Engineering Solutions. We're basically specialist consulting engineers for all matters to do with modular construction and factory setups and so on. So there's a lot to talk about here and not much time to do it. So what I better do is just quickly move forward and just to see what we can cover. So let's go. What do we mean by productized delivery? Where does it start? The power of BIM and the necessity for it. A non-automated example, a semi-automated example, moving to the next level. A word about machine languages, CDT, CVT file extensions, and so on. Then technology systems for full automation, what they do, how they can help, and how they rely on the IoT, Internet of Things. And basically, MES Systems, and I'll define what that actually is, but that's an essential part of where we're going in this journey. So let me just say first that the examples that I'm giving here are all 100% relevant and from the KSA market. There are some projects that I'm not 100% at liberty to discuss, but they're very exciting nonetheless, and I'm drawing some analogies and analysis from those. It was great to see earlier one of the panel members in your earlier session, Dr. Bandar from King Abdulaziz City for Science and Technology, to hear him describe the project that they're working on. And it is truly an amazing project by the sound of it. And to let you know that for the last 3.5 years, we've been an integral part of that project. And it's been my honor to actually work alongside Dr. Bandar. So first of all, what actually is Industry 4.0? And it basically, the continuum brings us from steam to cyber-physical systems. And firstly, obviously, it was water, wheels, paddle wheels, steam. Then with electricity available, there became mass production that was facilitated by assembly lines, then on to computers and eventually automation and robotics. And now we're into the 4th generation of Industry 4.0, and that's where machines are talking to each other, getting better, getting smarter, and doing things that were never possible before. What are the technologies? And I'll give you some examples of what those are that underpin Industry 4.0. This is sort of what the framework that you need so as to be able to benefit from the Industry 4.0. You've got smart sensors. I'll show you some examples of those, things that measure pressure, temperature, vibration, things that are connected to your alarm systems that alert you for predictive maintenance or an impending problem. The top slide is actually quite amusing, as somebody thought it was a good idea to put Internet of Things. I kept it just for fun, but that's IoT. The location detection, you need to know where everything is. And there are RFID tags, which are based on radio frequency. That's an excellent technology. And those can be even painted over, and those can be covered without affecting their signal. And then you've got normal barcoding and so on. So as sub-assemblies roll off the assembly line, all of the materials associated with that sub-assembly have been now withdrawn out of your inventory system. You've got cloud computing, which this is, it obviously is hugely important. And everything I've heard today has relied mainly on cloud computing. Advanced robotics, you've got big data, you've got lots of data, lots of ways to analyze the data to get better, to get more efficient. 3D printing, we've heard so much about recently, and is one of the will be a backbone for the future of modular construction. And augmented reality. And I'll just give you a quick example here of a situation that occurred in this excellent project that we're working on that is highly automated, highly digitalized, and highly roboticized. And a piece of sophisticated equipment has arrived and from New Zealand. But because the people who should commission the equipment and the machinery were not available because of travel restrictions, they sent a number of AI and AR goggles so that they could be back in their office and they could be instructing the officer or the technician in Saudi Arabia, in the kingdom, exactly what to do, which button to press, what actuator to initialize, and so on. So these are the basics. Productized delivery, we know about modular construction, but I mean, it breaks down to so many different pieces and sub-assemblies, many of which you're all familiar with, but we've got bolt-on balconies, modular wiring, MEP, pods, service cupboards for electrical and for plumbing, plant room skids, precast stairs, facade units, 2D panels, 3D concrete panels, and this one here in the bottom left corner is sits at the top of the food chain, a fully finished housing module that can be stacked, and these fit into any building where it needs to be used. So rolling on, the role of BIM is crucial in underpinning what we're doing and what we need to be doing. People give lip service to BIM in many ways, and I'm glad to see that there's more and more adoption. But quite often when you scratch the surface, there's only a very, very short and shallow understanding of A, what it is, and B, what it can do for you. So without going into all the full definition from Wikipedia, it's basically a digital representation of the physical and functional characteristics of buildings and places. That's it. That's what a BIM model is. And you can import design details directly from your manufacturer and place them in the BIM model. You can review the physical and functional characteristics, which helps later with facility maintenance. You can review the logistics details. You can make sure a module or a pod or a particular subassembly can physically get into the building. You can review, as some of your previous speakers have spoken about, 4D and 5D, where you can review cost and time. So let's take a look quickly at sort of a manual process that involves the creation of an MEP module. So that's your, let's say that's your product, okay? And here it is. It's a fairly standard MEP module with all the normal services, duct, FCUs, hot and cold plumbing, firefighting. You've got your cable trays and containment. So that's what it looks like, and a connecting frame, all 6 meters long. Great. How do you get one of these done? Starts, whether you're a consultant, subcontractor, or a manufacturer, with the consultant's drawings. Then you do a module layout, which basically pencils in the scope area that is relevant for prefabrication. Then this is where the magic begins to happen. You do the coordinated 3D layout, basically build a BIM model of the relevant area, and you can look at exactly what you have in a digital twin. I would much prefer if in the future the magic began out here with the consultant's drawings. There are some times where a full BIM model is passed through the system, but quite often it's the subcontractor that needs to prepare their own. In any event, thereafter, for approval, you submit a final client drawing. And then this would be for internal consumption production drawings of each module, each frame system, and then the bills of materials, which you use obviously for inventory and procurement and for costing purposes and for bidding. So that's the journey, and that's a manual process, okay? But you cannot go forward without, with certainty and with confidence, without having what I call one version of the truth. And that's a fully finished BIM model. We look quickly at a bathroom pod manufacturer. People are familiar with the concept. The main two components, in very simplistic terms, your pod floor slabs, plus your light gauge steel pod frame, which is a pre-engineered structure. And that gives you the basic building blocks you can fit out to produce a bathroom pod. Now, looking at this in practical terms, you've got many penetrations through the LGS frame, and those are engineered into a system that again starts with your frame drawings, moves on from there to your CAD file, which goes to your file conversion software, which then you get an introduction to the initial file language for your LGS roll form machine, which is a CVT file. And that produces your LGS light gauge steel frame pieces, which then, when put together, give you a structurally sound frame system. So this would be an example of the semi-automated system. How far do you go? Do you want to just reduce your manufacturing costs? Do you want all of the above? Do you want faster order fulfillment? This is what you need, a warehouse robot. You can have a machine vision inspection system. There are a number of options. You want them all of a sudden it becomes a very busy place. And you can't run this busy place with confidence unless you've got a proper MES system, which is basically a manufacturing execution system. And that is what joins all these dots together. You've got temperature alarms, sensors of all sorts. You've got the RFID and the barcode tagging. You've got vibration alerts, and everything is thrown up in through the MES system, which staggers the workflow. The MES system, as I defined, the manufacturing execution system, sits right below the ERP system, which you've heard quite a bit today. Below that would be a set of software and actuators, which then speaks to the machines. So from a daily or monthly cycle time to seconds, hours, and then milliseconds, this is where the MES system sits. And quickly, and this is nothing to do with any project that I'm working on or have worked. These are all generic details. But I just wanted to show you an example of the way that MES system will activate a roll form machine, a framing station, a cutting and drilling screwing bridge, and a high-speed painting and drying system, and the AGV transport robots, which will bring you and refresh your raw material supply. It's the sequencing that is the magic to this, and the MES system is connected to all these machines, knows what's going on, speaks to it in its correct language, and allows for the machines to work in a balanced format. And, you know, it's amazing when you start to speak how quickly time passes by. But I've never spoken as quickly before as I am now. And I just wanted to quickly touch on the main points, that the building block that you cannot move past with confidence is BIM. And we need to be living and breathing in BIM in a full digital twin sense. And there are a number of software types which are more suitable for some projects than others. I know you've got AutoCAD, AutoCAD MEP, Revit, ArchiCAD, SolidWorks, Solid Edge. Some are better for other projects, some are better for construction projects. Second, time must be allocated to do correct design so that you act like, and the old carpenter would say, I measure 3 times, but I cut once. This design must be 100% and time needs to be allocated for this. And unfortunately, this is not the norm. And we don't all need to be experts in the detail. I could have immersed in so much more detail in the robotics and automation, but time permits only as far as we've gone. And I just wanted to wrap up there, hopefully in time, and just to say, well, look, thanks a lot. Are there any questions?
Now, you're talking about technology-powered modular. We're seeing more and more discussion around modular, and indeed, we've seen a lot of discussions today that have suggested that for Saudi Arabia to meet some of the ambitious targets it's got, it will need to actively use modular. But what I'm trying to just make sure I understand correctly from your presentation is, you're talking here about just one aspect of these technologies can be linked, or do they all have to be linked for this to work efficiently?
Well, here's the thing. If you're to move the needle meaningfully on the housing issue, for example, in KSA, in the Kingdom, you need to be able to move at scale. You can't have a scaled production system that is manual. Having a fully automated assembly line, in fact, it would be more akin to automobile production of the most modern type, with a virtually hands-off approach. These are the technologies that are required for you to be able to create a technology that can be built in a factory, that can be produced at scale, that can then move the needle. And this is the issue, and I believe Dr. Bandar even referred to that earlier, in that while this is a government-backed initiative, and I'm delighted to be working along with them as part of the technology provision and project management, but this is something that is then going to be turned over to the private sector for the replication of numerous factories producing, let's say, 5,000 villas a year per factory throughout the different geographies. But to enable the factory, you need to at least not understand these technologies, but to be able to understand that they are necessary, and to be able to embrace the process that leads you to the to having a factory that produces at scale a product that people want.
So in terms of skills that are going to be required for the future, if this approach is taken, because you're talking, as you said, about a very manufacturing or factorized based approach to building, and I've certainly spoken to many people in the construction sector that have pointed to the automobile industry and said that construction needs to adopt a lot of its practices, because then it becomes much more efficient in its approaches. What skills are going to be required for this? Is it skills that are maybe not in skills that exist, obviously, but skills that are not maybe in construction today, they're in other industries?
Yes, exactly so. That is exactly right. That the types of jobs that would be created, you would be replacing 90% approximately of the low-paid casual or low-paid labor that is the backbone of the construction industry now. And that is one of the key points of Saudi Vision 2030, as well as provide good, high-quality, high-tech jobs, sustainable jobs for Saudi nationals. So the particular one project that we're working on with Dr. Bandar has some great targets of 80% completion in the factory, and we've been able to achieve 75% Saudiization. And these are jobs that young, qualified Saudi nationals want. And, you know, they're more akin to fighter pilots than construction workers. These are people who are working in AI, people who are monitoring tablets and screens around the factory, making sure that predictive maintenance is done on time. And it becomes a very immersive digital world that's producing a product that you can sell, that makes money, that allows for this to happen and moves the needle in the housing market, but at the same time providing excellent jobs that will stimulate the Saudi workforce. But these are not people who are necessarily coming from the existing construction industry.
Okay, and also this is going to fundamentally change, or will it fundamentally change the upfront design? Because obviously you're not going to have practices such as changes partway through the development.
Yeah, good point. And as Dr. Bandar had referred to earlier in his discussion, in his panel discussion, it wasn't so much mass production, but the target was to allow for mass customization. So, for example, when you buy a car, you've got a selection of options for your music system. And in the underpinnings behind the dashboard of the car are all of the basic brackets or whatever to receive any size digital screen or any radio or player size, whatever it may be. So these are built into the underpinnings, and this would be a sort of a parametric library of pre-designed units that allow for customization on a client-by-client basis. So each client has the ability to configure via an online configurator the particular dream home for themselves within a library of parts. But it's such a broad library, and you know, when you think about it, a robotic arm that is cutting and drilling and screwing and moving things around doesn't know what its next task is. It's told what to do. So the fact that it might be doing several different things and making several different designs and putting, you know, sockets and plug holes and switches in a different location on each panel is no problem to it. Whereas doing things manually, that becomes an issue, and the human factor comes into play. With automation and robotics, this becomes much less of a factor, especially when you have engineered parts that allow for this to take place and a system that facilitates that. So these are some of the issues that have been pulled into a recent experience, and very exciting it is too.
Thank you, Patrick.